Hey guys, so today we're going to talk about the activity that you'll be participating in your table groups. So the first things or the first items that you're going to actually get are you're going to have a yardstick that's going to be used for measurements. All right. You're also going to get a display or a piece of paper that has a piece of wood on it, and this is going to be used for our launches, okay? And then you are also going to get an information sheet, and this is going to have some information that we are going to need in order to do our calculations using the formulas for calculating what our force is and what our speed is, okay? And then you will also be getting a toy car, and there's a place here that is going to hold a washer. And that's all the material that you're gonna need for this project. The next thing that we're gonna talk about is how you are gonna use these materials in order to actually complete the activity. All right, so let's talk about the actual experiment or the activity. So you guys have your distance board here, the piece of wood. If for any reason the paper is kind of bowing up here a little bit, you can take the masking tape, I'll have it at the front, and go ahead and just tape the paper down. And you can do that on both sides. Your yardstick is going to be at the edge here where the car is going to impact. Okay, so when this car rolls down and it impacts her, this is the start. So that's our 0. And then we're going to use inches to see how far that washer is being launched, okay? So your actual startup. So you guys have 8-inch release, you have a 10-inch release, 12-inch release, 14-inch release, and a 16-inch release. So what I want you to do is these toys, these small cars, they are crankback cars. So I'm gonna crank it backwards. And once you hear the clicking sound right there, that's when you're gonna stop, okay? So now I put my washer on the top plate here. Make sure it's at the back of it. And what I want you to do is release it behind the line. So I put 2 fingers on it. I'm going to lift up and observe how far the washer goes. Okay, so that was a pretty good launch. If you launch the washer and let's say it hits the meter stick here and falls like that, I wouldn't count that. I would bring the car back and redo it. If you launch it and the washer rolls, right? It rolls on its edge and then goes flat. Again, I would redo it, okay? Because those aren't accurate launches. We want the washer to be launched and stay flat as it moves down the actual table, okay? So that washer ended up here. So on your worksheet here, you have 5 different trials, okay? So again, if you have to redo one of those trials because the way the washer launched wasn't correct or what we were kind of looking for, redo it and record your answer. So that first launch for me was around 6 inches. So the best way to get an accurate reading for how far it goes is to make sure that your meter stick is right on the edge. So this is our 0. And let's say the washer fell like right about here. I would take my pencil, use that edge, and at the end, at the very edge of that washer, come across and see where I end up. Okay, so I'm about at 7, right? So I would be 6 inches and 7/8. Okay, so I would record that on my worksheet, 6 inches and 6 7/8 of an inch. record that. Don't worry about doing the forces yet, okay? You'll do that once you get all your trials done, all right? So that's kind of the way, that's how you are going to utilize the toy car and the washer and the other parts that go with it. Before you start the experiment, what I want you to do is create a hypothesis or a prediction. What do you think is going to be similar? Do you think that if I release the car at 8 inches, my washer is going to go 8 inches? Or is it gonna go less? Is it gonna go more? And as you start moving back, is this going to increase or decrease, right? So think about it with your group. You're gonna all come up with a prediction based on how you think the force of impact is going to affect how the washer launches and also how far it launches as you start bringing it back, okay? When you are ready to do the force calculation, this card is going to give you a lot of information. You have your formulas and you have your unit of measurements. You also have the times, all right? So in order to figure out what the speed is, you need to know how much time it takes for the car to get from 8 inches until the impact, okay? If you have any questions, I will be walking around and helping you as needed. All right. All right, guys, so once you have completed your force calculation and you recorded the distance the washer was launched at, the next part is very similar to the engineering design process, and that is evaluating the results of your experiment or the results of the project that you just finished, right? How well did it work? In our case, we're evaluating what we saw, right? So we want to understand if there is a correlation between the distance that the car is traveling to the distance the washer is being launched at, right? So on your graph, you are going to record all of that information, okay? So you're going to do a bar graph and you'll shade in, and at 8 inches, you will write down how far your washer went. And then at 10 inches, same thing. And that's gonna kind of give us a visual to see if there's an increase or decrease in how far the washer's going. So we can better understand the physics that is behind what we have completed or the experiment that you have just completed.